Alrighty, so here we go. Now we got in parallel, okay? And I'm going to actually show you two different ways to do it. So the first, let's see, we have 9 volts here for power supply. I have 11 and I have 18, okay? So first way would be first figure out our total, which means if I were to redraw this as just one circuit, what would be the resistance of that circuit or that one resistor? So we talked about it before. The equation 1 over R total is equal to 1 over R1 plus 1 over R2, and so on and so forth. As many resistors as you got, you could add up there. Now again, it's not that the answer is equal to 1 over R1 plus 1 over R2, but 1 over the answer is equal to 1 over R1 plus 1 over R2, which means you could do a little fraction math and figure it out. But I also showed there's a shortcut before. So R total, if you have a good calculator, you could rewrite that as parentheses open up 1 divided by R1 plus 1 divided by R2 and so on and so forth, okay? But then you just have to take the inverse, which is on your calculator. It's probably the button above your squared button on your calculator. So that's what I'm going to do. So I'm going to do 1 divided by my R1, which is 11, plus 1 divided by my R2, which is 18, close parentheses, and inverse it. So I'll put that in my calculator. 1 divided by 11 plus 1 divided by 18, close parentheses, inverse, and I get an answer of 6.83 basically ohms. Okay? So now that you know our total, I could just do my Ohm's law, V equals IR. This works for a resistor or for the whole circuit. So Ohm's law is going to be, I want to look for current. So I is equal to V divided by R. So my total resistance over my total voltage over my total resistance was 9 divided by 6.83. And I get 1.32 amps. Okay, so that means I got 1.32 amps going through the whole thing. Now, or 32. Now, I want to show you something real quick, though. There would have been another way to get this. The other way you could do is just look at each branch and what the current is going through each one. So if I look at the current here, I'm going to call that I1. And I look at the current there, I'm going to call that I2. Okay, I could do Ohm's law for each resistor. Because again, the voltage, if it's 9 volts here, okay, if it's 9 volts there, anything in parallel is also 9 volts. So I could do that. I could say, all right, current I1 is going to be 9 volts divided by 11 ohms because it's V over R. All right. So I could do 9 divided by 11, 9 divided by 11, and I get 0.818 amps. Okay. Now I do I2, the other one. Well, that's still V over R, which is going to be 9 divided by 18. So 9 divided by 18 equals 0.5. Well, duh. Okay, so what if I add these together? So what I just figured out was that I have 0.818 going through here, 0.5 going through there. What if I add those two together? So 0.5 plus 0.818, I get, oh, hey, look at that. Once again, I get 1.32 amps. All right, because they would meet up over here and still be the same value.